I welcome you back after this our short so-called coffee break. So now, when we are doing any type of transformation, the one thing is a bit clear that we always want to replace these gray level with the another value, right? So that we want to see. And so what is once we are aware about this information, so one thing is sure that see what is given, this gray level is given and number of pixel is given, which is required for any histogram. Thereafter, we have calculated the PDF, probability distribution function. Thereafter, we have calculated the CDF, right? If we have calculated, so how we have CDF calculated? The 0, then 0 plus 0, 0 plus 0. In first case, it is same, 0.24 to 0.24. Thereafter, CDF is cumulative. It has been adding up. The initial value has been adding up and it has become 0.24, 0.56 to 0.8, 0.8 to 0.2111 in this way. But remember, this value is nowhere. How can it replace a gray level value? So definitely we need to do the some more operation. So what operation? So one operation is bit clear that you have to multiply with the 7. So once you will become apply with the 7, so the value will go nearby 7. And thereafter, what you need to do, again, you need to do the round off. Round off to the nearest integer value. It is 1.68, it is 2, 5.6, it is 6, and 7, 7, etc. This is it. So that's we have done it. So what will be the new histogram, new image? So whatever earlier gray levels were there, they will be replaced by this value. That is happening here. But anything, so what is your observation? Any question or any difficulty, whatever, please feel free to ask. So are you with me? So is it bit clear? See the initial gray level. See, so what I am asking here that when we are basically in histogram equalization, we are replacing the gray level, this gray level by this gray level. Is it normal or is it somewhere something is not uh, correct or incomplete? With respect to the concept of histogram equalization. It is normal distribution. Okay. Any other observation? So what will happen, see, when we have taken the earlier image, so what will happen in this image? So whatever this 4 level is there, it will be replaced by 4 will be replaced by 6. 5 will be replaced by 7, right? 3 will be replaced by 2. That is it clear? See, what will be the new image? What will be the transformed image? Because see, as a user, we are interested in the new image. Doesn't it really doesn't bother me that what you are doing. I really want to get the enhanced image. If it is enhanced, it is fine. If it is not enhanced, it is of no use for the user. See, one thing if you so and last guess anyway, I think what is not normal? Okay. So see, if you see here, one thing again, go back to the concept. Whenever you want to understand anything, if you go back to the concept, what is happening there? See, if you see the diagram here, see all the things are basically what we are saying. It is uniformly distributed. It is all the points are there which have been covered. But if you see in this example, see it is not so. It is many points have been missed. That's why it is very much clear that when we are taking this one, it is a fictitious example only. Only we are demonstrating the mathematics. It can't be an actual histogram equalization. That's we want. Whenever we are doing the problem, that feeling should come into us. Okay, that is only fictitious one. Even we are solving, even doing the calculations like of histogram equalization, but it is not histogram equalization. Do you agree? See, are you with me? Uh, Yes, Devashish, Shruti, thank you. So this is very much clear that even we are calling it histogram equalization, but it is not histogram equalization. You should have that much clarity whenever you are doing anything because you will able to know. Otherwise, what is the normal weakness of the students and the researcher that they blindly solve the problem, they blindly apply the formula, but they never ever able to feel it that what is going behind the data. See, you need to, as soon as data comes, you need to visualize it, you need to create the image of it, that yes, that's happening. If you are able to do it, see, you are likely to be, nobody can stop you from doing the good research and excelling in the field. Only key that can you visualize the data. This is the way we people able to visualize the data and see. So this is after, so this is basically the output. This is the input image as we demonstrated that this is basically the output image and that's how it has been shown here. But as we have already made it you clear that only we are showing the mathematics, otherwise it is not the actual equalization. I think now go back to our original. So this is basically histogram equalization. Here it has been shown. Go back to started. So coming to this problem, question number 36, get the, so can you do it? Is it a good problem for histogram equalization or for histogram stretching? First question to you. See, I repeat my question. Can we apply the histogram stretching here also? Why, Shruti? Why so? Sojan is saying we can apply the histogram stretching. So I need more opinion. We need more opinion to have the clarity on this question. Can we apply the histogram stretching on that data? Snehal is also saying that we can apply the histogram stretching. So it's a fragmented opinion. I request everyone to give out their opinion clearly that can we apply the histogram stretching here in this problem? No need to wait. hesitant. Whatever you feel it, definitely you are going to clear it. See, I repeat my question again. It is not that difficult. It's either yes or no. You have to say. Many people are saying basically yes, many are saying no. So that's why I want those people who have not answered to come up to have the clear majority in either of the side. See, what we are saying that whether in this question number 36, with the data is given, where on the R is basically the gray levels are there, and the N is basically that the number of that gray levels in an image, which is basically of the size 64 by 64. Can we apply the histogram stretching on that data? Write it. Can we? Those who are present on the terminal, those who are watching it, please respond. Whatever be the answer, it doesn't really matter, but at least we can have some decision. Jyoti is saying yes. Okay. Snehal to other present people who are present or who are able to write it, please write it without any botheration that whether right or wrong answer. Pravesh, are you here? He is still also saying yes. Okay. We can apply, but the result will be the same. Okay. So very good. So see, absolutely. See, if you see here, now see what I want to emphasize upon, actually, again, see, recalling the same thing, that if you take it, see what is the maximum level here. First, we go through it. This is 7 upon R max minus R min. What is R max? See, we write the formula. It is R max. R min. R minus. This is the one, right? So R max, what is R max here? R max, if you see here, it is 7. 81 values are there for the 7 grayscale. What is the minimum? Minimum is 0 here, right? So what we write? 7 minus 0. 7 minus 0, it is 7. 7 upon 7, it is equal to r minus r min, and r min is 0, so there will be no change in the result. So even if you will apply the histogram stretching, it will not lead to any change in the image. That is we want to tell. So even you can even see the formula can be applied, but it will does not result any change. The data will remain exactly same as it has been mentioned by the last one, Aditya. Yes, Aditya pointed out result will be the same. There will be no transformation. That's why we need to go through the histogram equalization. So is it clear? See what I want to emphasize when we had been asking this. See, is it clear? So how will we apply the histogram equalization here? We have seen the problem. So how will we apply? Yes, okay. So how will we apply the histogram equalization? So this is given, this R is given, this N is given. What will we calculate after this thing? Can you tell? P of K. It is PDF. What will be the PDF? 790 upon 4096. 1023 upon 4096. 850 upon absolutely. 4096. 656 upon 4096. 329 4096. 825 upon 4096. 120 upon 4096. 81 upon 4096. What you will get when you will calculate the value? So can you guess what will be the, can you tell the new gray level for the 0 and the, not for 0 and 7, but basically this probability distribution function. Can you tell the value for 2 and 3? What will be the one value for 2 and 3? 0 के लिए तो वो 0 ही रहेगा, इसलिए मैंने आपसे सी दैट्स व्हाई आई नॉट आस्क्ड. तो 7 के लिए भी वो 7 ही रहेगा. But for 2 and 3, can you tell what will be the new value? Can you calculate a paper and pen? 850 upon 4096. If you calculate, see what you will get. Can you calculate? I am using basically calculator of my mobile. It is 0.207. Point 2. 656. 56 divided by 4096. Can you tell what will be the value? What will you do thereafter? बाद हम क्या करेंगे? Can you calculate? Once we have calculated, it will be calculation for all the time. See, again, see, if you remember, see, what do we need to do? We need to basically find out this value also, because if this PDF is not sufficient, we need the CDF. So for CDF, these upper values are required. What will be the upper value? You need to calculate 790 upon 4096, and what will be this value? What will be this value? Can you calculate? I think everyone would have a mobile. Should able to calculate. It is 0.19. What about this value 1023 upon 4096? It is. Can you calculate? This is basically hands-on session where you are doing it. I don't want to make it in a lecture form. That's why a bit emphasizing on asking you the questions so that you will able to feel it. What will be this value? 0.24. Very good. So we can write it almost a 0.25. We write up to 2 decimal, we can write it. Otherwise, it will be very good. So Shruti has calculated. So what will be the value? So now what will we do with it? We need to calculate the CDF. What will be the CDF? See, this is 0.2. Here it is basically 0.44 CDF. What about this one? It is 0.64. What is this value? This is 0.8. Now what will we do? One last step is there. इसके बाद हम क्या करते हैं? देखिए ये वैल्यू तो सब we can't substitute these values. What will you do? You will scale it up to what scale? Up to what maximum value? The hands-on session, you need to apply your hands as well as your mind. Yes, 7. Absolutely. So what will be the value? 0.19 divided, multiply by 7. 1.33. 0.4 you will multiply by 7. So it will be, what will be the value? 3.08. We have to calculate. What about this one? 0.64 multiply by 7. 4.48. What about this one? It is 5.6. So we need up to this value only. The other we can calculate it. So we can round off to nearer value. It is 1. It is 3. This is 3, and this is what? This is 4. Actually, very nearby case. This is 5. So new gray level will be 1345. We just check out the answer. So yeah, it is there. So here it is there. So here these value are there. Somewhere things are not right. It is 4096. We have done it correctly. 0.4465, 1.33L. This is we are done. 1 it is right. We check out 1 is fine. 3 is fine. This 4. It is actually 4.48. Here the thing is that it can be 5 here. 3, yes, it is there. It is a minor change will be there because here it is, I don't know how the things have not gone correctly. It is 4.55. When you have multiplied this one, uh, what value? This was value, this point, this one, 0.44. Here, see something is not gone correct. So 60.64. Anyway, so this is the thing. So this, how you calculate it. Is this, I think it is clear. So this will be the new one. So what will do? This is basically the one when you will calculate it. Is it clear? So I think it is answer. Any question? I think now you will never ever forget histogram equalization, histogram stretching. Any question? I hope see you are with me. You are not exhausted. Because see, we have the limited examples, but with these examples, we are totally able to visualize the concept. That is the best thing. Any question in this part, or we can proceed further. It's clear, should be. You have calculated all the values. You have taken the pain to calculate all the values. It's nice. I want assurance from everyone that it is clear, and if it is not clear, so please try to do it. Wherever you find difficulty, you can acknowledge it later. It is for concept. Now we this is the one, so equalize SK, this is there. What we are showing here, see this is 0, 1, 2, 6, 7, and it is. Acha. It is asking give the PSK for each S of K. One more part is there. What is this PS of K? So here we have already see, calculated. Why it is asking again? This is 0.19. We have already calculated it. See this one. See, is this answer is the same? See, one more part is there. I repeat it. See, I have written also. See, give the PSK for each S of K. Can you calculate it? You have understood the concept of probability. It shouldn't be difficulty. So my one of suggested answer, whether is it the same? Whether is it the correct one? Answer. Or is it not correct? See, are you? See, I repeat the question again. See, what we need to calculate. See, we have calculated everything histogram. We need to find out the PS of K for each S of K. So whether is it the correct one, the which one I have basically answer, which I have basically outlined, is it the correct one? Yes or no? Definitely it is yes only. Where why you are hesitant to say yes? That's why I'm thinking. See, please see it here. See, what we are seeing here. See, what is this written? Can you read it? What is this written? PDF. See what is this written? Basically, if you see here, this is class layer. This is R of K. This is N of K. Right? R of K. This is N of K. And what we want, this is basically, what is this one? This is P R of K. Right? We want to find out the value PS of K. Please see in the problem. So how can it be same to this one? So what is S of K? Can you point out what is the value of S of K? Output gray level. So can you, Shruti, can you tell the value of S of K? When value of R of K is 0, 1, 2, 3, 4, 5, 6, 7. What is the value of S of K? Zero to 255. No, no. See, if you see the problem here, in this problem, it is R of K is basically see, go to the problem. See, here it is 3-bit image only. 3-bit means so maximum value can be 1111. So it will be so total 8 value. So total maximum value can be 7 only. So it is from 0 to 7. It is the RK, R of K. SK is 64. No, see how can SK see? Remember, it is mapping only. So mapping only, it can't exceed the 7 because gray level can't exceed the 7. 64 is basically the number of pixel. See what is 64? I think this image. What is 64 by 64? I tell you very clearly. This is the one. If this is my image, here 1 to 64 rows are there, and 1 to 64 columns are there. Shruti has, yes, Shruti has right. She has written something. 0.023, 0.66 PS. Okay, yes, she has calculated. Yes, but what about other? Okay, let me check it. But first, is it clear? See, what is S of K? S of K, remember, S is basically the transformed intensity value. See how it is calculated. See, that's why we have shown it. You see, in this way we have calculated. See, in any of the technique, in any of the image transformation technique, we are always calculating the S of k from the R of k. But in this histogram equalization, this is the way. See how we have calculated it? You see here. See, this we have calculated. This was a 0 and it has become to the 1. It has taken 3 steps. First, we have calculated this way. We have calculated basically this nk upon n. This is 1. Thereafter, we have calculated CDF 0.19 plus 0.25 and 0.25, 0.25 plus 0.19, 0.44, 0.44 plus 0.21, 0.65, 0.65 plus 0.16 equal to 0.81, 0.81 plus 0.8, it is basically 0.89, 0.89 plus 0.6, 0.95. So then what we have done, we have multiplied this value by the 7. 7 into 0.19, it is 1.33. 0.44 into 7, it is 3.08. 0.65 into 7, this is 0 to 4.55. And then what we have done, we have taken to the nearest number. 1.33, it is round off to the 1. 3.08 to the round of 3. 4.55, it is nearest integer, it is 5. 5.67, it is to the 6. 6.23, it is to the 6. 6.65, it is to the 7. 6.86, it is to the 7. It is to the 7. So the new value, Sk, transformed value, it is 3. For 1, it is 3. For 2, it is 5. For 3, it is 6. For 4, it is 6. For 5, it is 7. Are you getting it? These are the new gray level in the histogram equalization image. This is the new one. Is it understood? Saujanya, you asked it how it calculated. So it has been shown, it is calculated. But how to see it is probability? See, we have gone through this now. We have gone through this one, this probability, this 790 upon this thing, this whole formula 1.33, it has become to 1. This is basically how many steps calculation? This is first step. This is second step. Third step. Fourth step. The fourth step you have calculated it. Now they are asking, see what is basically, they are asking what is basically PS of K. This is the problem. So exactly R of K is given. We have seen it that how do we calculate PR of K? So can we calculate PS of K when this is given? That's why I only want to emphasize up. SK, sum of SK, how are the values should be calculated? Yes, we will see it, Shruti. We will see the magic of Shruti that how did she reach this value. See, first remember one thing that there will be a key difference here. What will be the key difference? That R of K, all values are basically different. But when you are drawing the S of K, some value has become same. So what will happen? This 656 plus 329, this will add up. That will be the change. 777, this will be add up. So what will happen? So there will be so only limited these columns are there. This is 1, basically 790, 3 will be 1023, 850 will be, 5 will be 850, 6 will be how many values? 656 plus 329, it is 995. You are getting it. Here it will be the change. That's why. 985. Yes, it is 985. Correct. What about this one? This 3 value will also add up. 244. This is 366 plus 81. 447. Correct? 448. Yes, 448. Now what will we do? We will upon 4096. 448 upon 4096. 985 upon 4096. That we will do, and that we have done in this way. See this one that we have done. Upon 4096 0.19, it is 0.19. So that's we have calculated, and that is the answer. And we can check out that whether, so that's how Shruti has preferably calculated. Shruti, but somewhere you missed it, I think. It is this one. Just check out. So this is the one. So what is a cross check to see this thing, whether is it correct or not? P S of K. Remember, is there any way to check out that whether is it the correct one? Even very quick way that it will add up to the one. Blindly add up all the things, 0.19525. This is basically 0.44, it is 0.65, it is 0.89, and it is 1. So this is absolutely correct. This is the way. It, I hope it is well understood. All right. But we have seen it's with the hands-on session, you actually imbibe the learning, absorb the learning, what you have. So this is the question for you to do it at your assignment. So this is today's assignment. Apply the histogram equalization technique to the following image. Whatever value you require, you tell me. I will tell you, but tomorrow you need to come up with its solution. This is the assignment for you. Please note down it. No more NEC. Parmavakchi, this is the assignment for you people. You have been asking for assignment. This is the first assignment. And tomorrow, see, we will have you have the quiz. I think you are ready for the quiz. Maybe we have done the lot of it. And yes, expected. So you will have the two quizzes. Yes, I'm happy to see you, Dr. Parmai. She is very sincere candidate from the day we had been expecting hard. Access Canvas, I think, account, but haven't you log in there? People and you find out the way, see, what can be done for the Canvas thing. Because see, all the platforms based upon Canvas. Your assignments, your this thing. Measure assignment. So you uh, need to submit the before the yesterday's like it time is basically tomorrow. See, one thing more, tomorrow is basically class from 10 to 1. Instead from 11 to 1, it is 10 to 1. This is extra 1 hour. And then in the afternoon, it is the same like today. It is 2:30 to 6. So what will happen? 1 hour, 1.5 hour extra today, 1.5 hour extra tomorrow, and 1 hour in morning, we will compensate the Sunday. So tomorrow classes are a bit stressed so that see we can compensate that Sunday 10 to 1 in the morning and 2:30 to 6 as like today. But definitely 2:30 to 6 doesn't mean that we will have a full stretch like the histogram. Sunday class is not there. Saturday, see, let's see, Saturday also we will, if we can accommodate somewhere. But right now, see, we actually, last day is 24 actually. That's why. Submit. Yes, assignment, you need to submit it today till the 12 o'clock. Till today's date. It is 18th of December. In the Canvas account, yes, please try to do it. If, as a quiz also, see, we will have the quiz so that you go through that content, see whatever it is there. We'll have the quiz day after tomorrow that we can whatever see because see very important whatever we are going upon if we can absorb it because once we are able to absorb it definitely you all are working at some places but see once you are able to absorb it once then it is for all the time otherwise tomorrow never comes. If you have any question, so I think this is the problem. This is the problem. For any doubt you have, if you have any question regarding it, you may ask. Uh, no problem. But finally, I need that you are able to show that what will be this image. Here, basically, 3-bit. It is again your grayscale is basically by the 3-bit. Yes, 0 to 7. जो दिया है. 3 bits. So what you will do again? What you have to do? I tell you. This is first. आपको क्या कहाँ से where you have to start? आपको क्या given है? You will try. Okay. Okay, Saujanya. So that's it. So if it's you can do it, so we can conclude it. Or if you have the doubt, it is open. I think today we have done a lot of hands-on sessions, so I don't want to over digest, overburden the thing. On Canvas account only. So its answer will be discussed tomorrow in the class, in the morning class. We start with its answer. See, no problem. If you all remember, it's only the total weightage is there. See the solution in tomorrow's class only. So here today we can here it's the content all. If you have a question, etc., regarding anything, because see, today we have opened the things very much. Whatever we have done, we have tried to open those things. We have actually stressed ourselves. So it is very well image enhanced, very well learning, enhanced learning, I think. So quantum secret classes definitely. See, it is actually announcement there. See, definitely join it. So, so anything we can, or we can conclude it. Any suggestion, anything, whatever you want to give it, it's open. And I think we have sufficiently, I have stressed you doing lot of concepts. Actually, Sojani, I am not religious quantum. It is actually automatic messages are there, I think. No, right? But it's good. See, I hope see you will enjoying the thing on EICT Academy. What I mean is how the assignment submit on Canvas. Canvas, it is the same way. So haven't you submitted any assignment on Canvas earlier? Yes, yes, so it is the same way you have to do it. Mhm. So thank you all. Try to do the things, whatever these things are there. Even see, it is not suppose that you would have grasped everything because you would be traveling, would have been doing lot of things while doing it. Definitely, it's not that easy. But you can always come up. In afternoon sessions have been designed in such a way that there we are basically doing hands-on session. We are instead of covering the more content, we are basically going towards absorbing the content, towards relearning that content. In morning, we will cover the new concept, but in afternoon, we will take up the problem session only. Because what is another thing that after having the lunch, etc., it is not that easy to be awake, etc. So that way, this afternoon sessions are very, very complementary to the. So thank you. With that all, it's a wonderful session of the as well as of the image basics of the image processing with application. Is any other related to image processing, sir? Could you explain it? See, definitely see all these algorithms are related to the image processing only. We are explaining it. But see, thing is that in when it's a limited time course, a 10-day course, etc. So you don't have much time to emphasize upon. And see, what is the best way to do these type of problem? That's why I've taken up this problem. This is first. So that's why we have taken it. And see, main thing is that algorithms bit vary in their nature, but at the core, if you really understand that why this, how the algorithms are working, any two, three algorithms are working, then you are able to understand, then you are able to think in that way, on that line. Then see, that's why we are saying it that we are equipping you to read anything regarding the image processing once you are clear with these basics. content is see, content is large enough. It's not difficult. It's very, very difficult to cover the whole content and in a such a way that it can be grasped. So that's why we have put up the emphasis upon the fundamental and doing this hands-on session problem. That is the thing. Computer science definitely. Yes, yes, definitely. See, you work with the algorithm because see, when you will implement the things, even when you see actually what is happening these days in Python, etc., you directly find out. See, for the old algorithms, you directly find out the inbuilt function. But for the new algorithm, when you make up the things, you take up the new algorithm, especially in the research paper, or you are designing it, there you find if every step is clear, you really find it easy to write a function. Otherwise, for the old function these days, if you see the Python, etc., these things are already available. But that doesn't give you confidence actually. General AI or yes, the generative AI or CNN algorithms, definitely this is a different course. Basically, it's the machine learning, deep learning, its course is there. Yes, yes, can implement these things. This is actually the most, this is the final level of the image processing where people are working. But here, different people are there in the classroom, in the batch, so it is not always preferable to directly go to that highest level because only few will be benefited in that case and other will be suffered. Concluded. We have no more any comment or any question. Thank you. Thank you all for your wonderful participation, support.